Hello guys, today I will teach you the short circuit calculation from switchgear till transformer till bus bar till circuit breaker and till our three-phase motor. So I will tell you that which parameters are necessary to consider while calculating the short circuit from the first point till our 6 point, and 6 point is the terminal of the three-phase motor. Okay, the first thing to note is our grid is 500 MVA, so we have to find the fault current at the grid side, or you can say our bus bar of 33 kV. We know that the fault current formula is like V is equal to IR multiplied by √3 for three phase, and this is the factor that we consider 1.1 or 110% to take into account when we calculate the short circuit. So here our Z naught is missing, that is the impedance, and impedance formula is V square over S. This is the same formula as P is equal to V square over R. Here R is substituted by the impedance. So we know the voltage, that is 33 divided by S, that is our apparent power, that is 500 kVA, and by using our calculator we found out that it is 2.178 ohms. Then we simply put this value here, the value of voltage we already know, and then we come to know that it is 9.6 kiloampere. So the first short circuit calculation of the current, short circuit calculation of the grid is found out to be 9.6 kiloamps. So this value is at this point. So we have one cable that is connected via 1 cross 3 cross 300 square millimeter. I have the data sheet and the characteristics of this cable just to find out the Z, as we already calculated, and then we have a bus bar of 33 kV. So to find the short circuit current at the point 2, that means at this point, we have to know the resistance of the cable that we found out from the data sheet. If you don't know how to calculate the resistance from the data sheet, you can see my other lectures on my channel. I already explained from the data sheet how you can see and calculate the resistance. Then we have the length, that is 1500 meters from grid to the bus bar. Number of runs, that is how many cables are running. So we have one cable. 3 means we have one cable of 3 cores, but it's a one cable. So number of runs is one cable. And then we have to find the R cable, any resistance of cable actual. Actual means by considering the length. So we have to multiply the resistance with length divided by number of runs multiplied by 1000. So we will get this value. Similarly, we have to calculate the reactance exactly in the same way. You can find the reactance from the data sheet, and we found it to be 0.15. The formula of the impedance is impedance square is equal to R square plus X square, and similarly square root of R square plus X square if we have to find the impedance. By putting these two values we get 0.25. And then Z total. Z total means, if you remember, we already calculated Z naught at this point, and now we have calculated Z naught at this point. So the Z total is the summation of these two values. So by adding Z cable this one and Z cable, Z not this one, we got Z total as 2.425 ohms. And once we found the impedance, it is very simple to find the short circuit current, that the same formula that we are using, and this formula will be used till end of this lecture. So just putting the values, and the most important is this Z value. We found out that 8.6 kiloamp is the short circuit rating at this point. And by adding short circuit current rating at this point and this point, we make it a rough value of 25 kiloamps. You can see here we have 8, before we have calculated 9, so it is like 17. So we make it roughly 25 kiloamp just for bus bar. So our third part is to find the short circuit rating at this point, because we have a cable, and then we will calculate after the conversion. So at this point, exactly same formula, same concept, nothing is changed. Like we have to use the resistance of the cable, length is 25 meter from the bus bar, till the start of the transformer. Then we have the number of run, resistance of the cable, reactance, and finding the Z cable, and then Z total. In this case, Z total would be this one plus this one. So what I did, I just make it Z total 2. Like Z total 2 is the summation of Z cable plus Z naught. So in this case, just for simplicity, I take Z total plus Z cable, and the value would be this one. You just have to put the value here, Z total 3, and you will get short circuit 8.62 kiloamps at this point. Again, once you calculate the Z impedance, you have to take into consider Z of this point, Z of this one, and Z of the grid. So the fourth point is to find the short circuit after the step down transformer at this point. That is our number 4. Okay, here is go. So the impedance value of the step down transformer is the percentage multiplied by the voltage square divided by kVA divided by 1000. So how we can remember this formula is using just simple Ohm's law, and this is like this one, V square over P, and V square over P like kVA, what is the rating of the transformer, and then the impedance percentage of the transformer. Now go to the transformer. We are using transformer step down from 33 kV to 6.6 kV. The capacity, the rating of the transformer is 8 MVA, and the impedance of the transformer is 8.35. This data you can find on the name plate of the transformer, or you can see the data sheet. So just put the values. Z is 8.35, as I already told you, multiply by 6.6. Take note, it's not 33, it's 6.6 because it's a step down. Then kVA is 8000 because we are using 8 MVA, so in kVA it's 8000, and then divide by 1000. So you will get this value. Then the total impedance. Now we just find the impedance conversion of the transformer, but at this point what we will do, it's not only just a summation. We have to consider the secondary voltage square divided by primary voltage multiplied by the ZT3 total 3, that is this value, plus ZC, this value. So putting all these value, we will get Z total 4, that is 0.55. And in our famous formula of short circuit, we will just put these values, but take into account this voltage. Now we are dealing with the secondary side here, this side. So 6.6, and by putting the values we will get 7.58 kiloamps at this point. So whenever there is a transformer, you have to take into account these two steps for the short circuit. I will teach you all these things in the ETAP electrical software, but first it's good to have a manual calculation. It's very important. So again, you have to remember these two steps for the transformer, and the important step is this one. Once you know this formula, like secondary voltage divided by primary voltage multiplied by impedance of the transformer plus total impedance, then you will find the required value. Now our fifth point is the short circuit, because the cable is involved from the transformer till the bus bar, so we have to calculate the impedance. But remember, now we have 3 runs of the cable, one cable of 3 core, and 3 cables are running. So in this case we have again to calculate the resistance of the cable by using the formula that we already used here. So I quickly multiply with the length, that is 25 meter, number of run 3 multiplied by 1000 is equal to this value. The reactance, the same formula, this value, and the Z cable of from this to this point is this one, and Z total is this value, this value, this value plus this value till this value, Z total. So is 0.55, and you will get 7.5 kiloamps. And finally we have to calculate the impedance till this point. Again, a cable is involved, same formula, resistance actual. Here we have one number of cable, so we will put 1 here. 180 is the length, and the final value is this one. Similarly, the reactance is this one, Z cable is this one by multiplying, and the Z total, calculating all the impedance till the end of the motor terminals, is 0.6, and by using the formula 6.6 kV we will get the short circuit as 6.917. So you can multiply this value with 6, because due to the starting of the motor you have to make some compensation. But the main concept of this one is how you calculate the SCCR, short circuit current value. Thank you so much.